Okay, so I just want to do an overview of how I approach sort of taking our algorithms and writing code from them. So I'm going to do that using an insertion sort example. And so I'll just get some data. Whoops. There we go. So, 50, 20, 30, 10, something like that. And I want to run insertion sort. Okay. And so how do we do insertion sort? Well, if we sort of think about it, if we remember, we have two lists. One is a list that is sorted, and the other is a list that we don't know whether or not it's sorted. So we assume it's unsorted. And the sorted list, of course, starts off empty. Or another way to think about it is maybe it doesn't start off empty, but it starts off with one element because a list of one element is in itself sorted. So we have this sorted list, and we have this unsorted list. And in insertion sort, we progressively take the elements in order and we insert them into their place in the sorted list. So we're going to track through every element. 20 is going to go into this list at some point. 30 will go into that list at some point. 10 will go into that list at some point. And for me, when I see something like that, we're going through each element, I immediately think, okay, for loop. Anytime we're going to perform substantially the same process across the entire array, for loop. That's what I think. So I would write something like for int I. Now, where does I start? Well, we could start it at 0, because we're going through every element. We could also start it at 1 because here's our indices, 0, 1, 2, 3. And so since a list of size 1 is by itself sorted, we really only need to look at indices 1, 2, and 3 up to the size of the array. So I'll start at 1. It's a small optimization, but it's nice. And then we want to go through the entire array. So while I is less than R is what I'll call the array.len length. And then I plus. So there we go. I will also add a comment here. Go through each. Oh, what happened there? Go through each element in order. And then we also probably want void. Insertion sort. Int array R. Like that. And okay. So I'll put my closing brace there. And now, when I look at something like this, I'm going to focus on what are the mechanics for inserting each element. So if I sort of simulate it, to insert 20 into 50, I have to compare. So is 20 less than 50? And it is. So I'm going to swap. Yeah. And so now I would get 20, 50, 30, 10. And now this is, I'm still in this process of inserting because I don't know that I'm done inserting yet, at least from the point of view of the computer. I know 20 is less than 50, but suppose there were more elements over here. If there was something there, that was that, I want to keep on inserting 20 back. But in this case, and I could use this same check to move 20 further back in a loop. But in this case, we're sort of out of space to check. So we probably want to check not just that 20 is less than the element we're considering swapping it with. We also want to make sure that if we're at the end of the array, that we know we're done. So I guess I will say 2 checks. To swap. So we want to swap as long as the previous is greater than, because the previous element is 50. So this is just sort of reordering 20 is less than 50, so swap. I'm instead saying 50 is greater than 20, so swap. And just so we, no, yeah, that's fine. And then the second check is we want to make sure we're not at end of list. So those are the 2 things we need to do to swap. And the other thing to note is because this sorted list could contain sort of the whole rest of the array, like the sorted list is going to grow. It's going to be something we iterate through. We probably want to use a loop as well, because anytime we sort of have multiple things we need to perform the same check again and again on, a loop is going to serve us well. And so I'll use a while loop in this case. The first thing I want to consider is what are the bounds of the loop that I'm inserting into? So if I'm just looking at this portion right here, the index that I want to insert into that list is actually going to be I, because I start I at 1 and 20 goes in first. Then once 20 is in, I increment I, and now I is 2. So I'll make a new variable, insertion position, and I'll set it equal to I initially. And then now I'm going to use my checks that I sort of broke down, that I got from my analysis. And while I want to swap as long as I'm not at the end of the list, so while I greater than 0, because when I is 0, then we know we're at the end of the list, because 0 is the first index, or really I should be saying the beginning of the list. And while the previous element is greater than the current element. So while array I minus 1 is greater than array or R of the current position. Whoops. This I should be the insert position so that it will fit. I'm going to rename the insert position J. So while J is greater than 0 and J minus 1 is greater than array of J. And I'll just close that there. So, and you can see sort of why I put this while J is greater than 0 check first. In Java, there's what's called short circuiting, which is, since both of these statements have to be true in order for the while loop to continue, if one of them is false, we don't even bother to execute the second one because we need both of them. So any one of them is false, we just ignore, we're just done. And so if j does equal 0, then we will quit. And if we didn't quit, we would actually execute array. We would try and index array at 0 minus 1, which would throw an exception. So the short circuiting is actually helping us here by helping our code be a little bit cleaner. Now, I'm going to close my while loop there. What's going to happen inside the while loop? We're going to swap. So I trust everyone has implemented the swap function. So we're going to swap the array at j minus 1 with the array at j. And then lastly, to sort of advance everything along, we'll decrement j. So that is sort of like starting j here, and then when 20 is moved here, now j is equal to 0 because we'll decrease 1 after swapping it. And so here's the code for insertion sort. This is a pretty canonical solution. There's a lot of other ways to do it. There's a lot of cool other ways to do it as well. So don't feel like you have to program it the way that I did it. One thing that I really enjoy actually is seeing other people's programs and seeing them take an approach that I had never thought of before. So this is how I did it, but you're welcome to do it in any way that makes sense. So there we go.